Hi. Hello everyone. Welcome to information sharing session on failure analysis. Part 2, Manufacturing Process Defects, their types and characteristics. In any failure analysis, it is necessary for us to understand the type of failure, failure mode, failure mechanism. Unless we put up failure definition properly, it will be very difficult to reach to the root of the failure. Different type of failures may have different types of failure modes and failure mechanisms. Hence, it is necessary to understand the types of defects due to which failure occurs in parts. But, before we understand different types of defects, it is also necessary to understand different types of manufacturing processes from which so-called defects are generated. So, let us first understand different types of manufacturing processes through a simple flow chart. Manufacturing processes are classified under two main categories: part operations and assembly operations. Part operations are divided into three categories. That is, shaping processes, property enhancing processes, and surface processing operations. Assembly operations are divided into two categories. That is, permanent joining processes and mechanical fastening processes. Shaping processes are further divided into four categories. That is, solidification processes, particulate processing, deformation processes, and material removal processes. Heat treatment processes are covered under property enhancement processes. Cleaning, surface treatments, and coating processes are covered under surface processing operations. Welding, brazing, soldering, and adhesive bonding are covered under permanent joining processes. Threaded fasteners and permanent fastening methods are covered under mechanical fastening processes. What do you mean by the term defect? A defect is a physical, mechanical, or aesthetic feature of a product that indicates that it failed to meet one of the specified requirements. Modern technology necessitates not only superior material quality, but also professional metallurgists with in-depth knowledge of parts obtained through various manufacturing processes. With the rapid advancement of materials and process technology, as well as their expanded applications in advanced engineering systems, the likelihood of failures in complex structural assemblies or components has increased due to the difficulty in managing defects in finished products. However, manufacturing defects must be strictly regulated to keep them to an acceptable standard, in order to reduce the chances of an abrupt failure occurring during the service life of a heavily loaded part. There are still too many failures during the initial stages of production as well as in operation. The existence of a number of defects in the products, either natural or caused during manufacture, is often blamed for these failures. Despite the use of strict controls at different stages of service and inspection, certain metallurgical flaws seem to go undetected. It would certainly be a potential hazard if the number of such defects exceeded the safe level, especially in critical application components. As a result, before and after secondary processing, a failure analyst must be familiar with defect characterization processes, including source, recognition, cause, detection, and remedial measures, involved in cast and wrought products, both ferrous and non-ferrous, such as rolled bars, extruded bars and profiled parts, forgings, welded components, and so on. Furthermore, understanding the effects of the defects in detail is needed in order to understand precisely how these defects affect service behavior and to determine the acceptability of the defects in a meaningful manner before certifying for use in service. Let us now have a brief understanding on classification of defects. A non-acceptable defect is characterized as a gross lack of consistency in a material, in terms of its physical aspects or properties, as opposed to minor discontinuities or blemishes that are less serious in nature. Depending on their linearity and sharpness, defects are often classified as propagative or non-propagative. This identification is needed to determine the extent to which these two types of defects affect the overall service life. Porosity, for example, is considered a non-propagative type of defect due to its circular or elliptical geometry. It has a less harmful effect than a crack of both linearity and sharpness, which can easily spread at a minimal stress of operation. In assembly, in order to interpret the magnitude of the defect's effects correctly, it's also important to categorize them as surface or subsurface defects when characterizing them. When hidden defects in the subsurface cause unexpected and often catastrophic failures in otherwise reliable materials, this assessment is critical. Defects in engineering materials usually fall into one of four categories. Defects that occur during the transition from a liquid to a solid state and during casting. Defects introduced during primary processing. Defects caused by secondary processing in addition. In-service flaws. Now, we will see defects associated with various manufacturing processes. In shaping process, we will see foundry operations. Foundry operations are divided into four categories: cast, ingot or billet, sand casting, die casting, investment casting. Defects associated with these processes are blowholes, shrinkage, porosity, misruns, hot tears, cold shuts, metal penetration, cuts and washes, infusions, fusion, drops, short metal, shift, crushes, swells, rattles or buckles, hard spot, spongings, warpage, run out, fins and flash. Powder metallurgy and metal injection molding. These two processes are covered under particulate processing. The defects associated with these processes are cracks, voids, porosity, oxidation, decarburization, carburization, agglomeration close to surface, blistering, sponge iron material and diffusion alloyed material with poor sintering necks, insufficient diffusion of alloying elements, sulfides due to S-rich sintering atmosphere, rust in the pores after machining, over-nitrocarburized, over-carburized. Deformation processes is divided into two categories: bulk forming processes, which include rolling, extrusion, forging, wire drawing, etc., and sheet forming processes, which include stretching, flanging, drawing, contour forming, etc. Defects associated with these processes are cracks, piping, burning, rupture, cold shut, wrinkling, blistering, distortion, heat checks, lap or fold, orange peel, overheating, delamination, exfoliation, central and forging burst, annular defect, decarburization, alligator's skin, funnel formation, surface undulation, push-through defect, hot and cold shortness, gas and segregation voids, longitudinal discontinuity, peripheral coarse grain envelope, undesirable grain flow pattern, low mechanical strength due to improper grain flow. Material removal processes. Material removal is done through mechanical, chemical and thermal processes. The defects associated with these processes are nick, scratch, ridge, grinding crack, burn, discoloration, hot spots, rehardening effect, softening effect, residual stresses, loss of dimension and GD&T. Surface irregularities, distortion, undercutting and rough surface, in chemical milling, hydrogen embrittlement or intergranular attack or pitting and corrosion, in electrochemical machining, craters or voids, hard chilled white layer, crack, heat affected zone, in electro-discharge machining, etc. Property enhancing processes basically include heat treatment processes. Defects associated with heat treatment processes are Quenching crack. Overheating. Coarse-grained or Widmanstatin structure. Burning. Decarburization. Oxidation. Scale. Crack. Retained austenite. Soft spots. Untempered martensite. Distortion. Warpage. Low strength properties in steels. High temperature oxidation. Discoloration. Surface blisters. Diffusion of cladding. Overheating. Low strength properties. Orange peel effect in aluminium alloys, etc. Surface processing operations are divided into two categories: cleaning and surface treatments, and coating and deposition processes. Defects associated with these processes are embrittlement, pits, blisters, flaking, discoloration, rough deposits, abrasion, adhesion failure, alligatoring, bleeding, bloom, bridging, bubbles, cathodic disbonding, chalking, checking, sissing, cobwebbing, cratering, crizzing, crossfooting, delamination, fading, grinning, heat damage, impact damage, intercoat contamination, cracking, orange peeling, peeling, pinholes, rippled coating, runs, rust, sags, settlement, skinning, solvent lifting, solvent popping, staining, undercutting, wrinkling, etc. Welding, brushing, soldering, and adhesive bonding are considered as permanent joining processes. Defects associated with these processes are incomplete penetration, incomplete fusion, crack, undercut, slag inclusion, porosity, warpage, flux inclusion, spatter, overlap, rough junction and irregular bead, shrinkage, distortion, fading, brushing alloy fails to wet joint surface, pin or blow holes, bulbous joint, lifted component, flux residues, outgassing, solder ball, solder flags, solder shorts, solder skip, sunken joint, mask discoloration. Defects associated with adhesive bonding process are non-uniform cure, poor cure and heat damage, micro-cracking and delamination, fiber breakage or fraying, fiber wash or displaced fibers, poor fiber alignment, fiber folding or pultrusions, wrinkling or kinking, poor ply abutment, local buckling or bulging, etc. Mechanical fastening processes include threaded fasteners and permanent fastening processes. Defects associated with fasteners used in these processes are crack, quenching crack, forging crack, forging burst, shearing burst, cracks or streaks in raw materials, dent, wrinkles, cut marks, damage, etc. In coming sessions, we will go through few of the defects in detail. Thank you.